Good morning, students. How are you and how is going your study? Okay, I hope it is going very good. Okay, so it's your mathematics class, and today we are going to learn about a new chapter. And I think you already know about the shapes and different kind of structure which we encounter in our daily life. Okay, so today we are going to learn about these shapes and sizes. How did we assume that what kind of these shapes? Okay, so let's start our new chapter. So I think you all know about this one. It's our lovely Earth, and this is a map of all the countries. And if you look at this circle, so it shows a specific country. This country name is Egypt. I think you all know about the Egypt, its mummy, its pyramid. So let's see what is happening in this country. So this is country Egypt, and this is river Nile, and there is a city which is called Cairo. So this city is called the city of pyramid. You can see a lot of pyramids here. Yes, there are lots of pyramids. So if you don't know, then I will tell you about the pyramids. Pyramid is a very big structure. Its vertex is in conical shape, and there is a base. It's kind of like this. This shape is called pyramid. So you can see there are lots of pyramids in the bank of the river Nile. But river Nile, uh, uh, this river Nile has been flooded during the rainy season. So you know, in rainy season a lot of water comes into the river, so it flooded out and it washed all the plains. So what did the citizen of Egypt uh, what option did they get to get rid of this devastation? So they made a lot of structure, and this is called a lot of structure to save these pyramids. And they measure the length of these pyramid of these structures. So what did they do? They measure the earth structure. This is called measurement of earth. Yes, they are measuring earth, and earth is called geo. So its Latin name is geo. And what is measurement? Measurement is called metry. So if we connect both these words, so we get our new branch of mathematics, which is called geometry. So this is a new branch which is called geometry. So geometry means, if we break the meaning of the geometry, so it means measurement of earth, because geo is earth and metry means measurement. So geometry means measurement of earth. So Greeks are the one to realize the need to conceptualize the geometrical ideas. Pyramids occupy a place among 7 wonders in the world, and whose construction is certainly one of the greatest human achievement. These pyramids are the 7 wonders of the world. These are a part of the 7 wonders of the world, and its construction is very huge. because it was the greatest human achievement, because the height of these pyramids is huge. It's not a very small structure. So the Greek philosopher and mathematician, there were a lot of Greek philosopher and mathematician who gave a very beautiful, who gave the structure to the mathematics. So these mathematicians are Apollonius, Plato, Pythagoras. I think you already know about the Pythagoras. He gave a theorem which is called Pythagoras theorem. And some more philosophers are Apollonius, Plato. There is a Euclid. He is also Greek mathematician. So Euclid collected all their contributions to geometry and other branches of the mathematics into 13 volume of books called the Elements. So this book belongs to the Euclid. His book name is the Elements, and it is a 13 volume book, and it contains a lot of theorems related to mathematics. So Euclid was a Greek mathematician, often called the father of geometry, and he is called the father of geometry. So who is the mathematician which is called father of geometry? Yes, it is Euclid, because he gave a lot of theories related to geometry. The picture of Euclid we have today is also through the imagination of an artist. So this is not a real picture of Euclid, it is just an imagination. Euclid deduced his results, what is now known as Euclidean geometry, from a small number of principles called axioms and geometrical postulates. So these are the principles. One principle is axioms and another is postulates. So these are two kinds of principles which were given by the Euclid. So these all are related to the geometry field. Greek people are the one who started using few terminologies related to geometry. So they gave the first and primary terminologies related to geometry. So first we learn what are the basic geometrical concepts, because we know about the we all know about the line, point, what is angle, okay, but we will start with basic geometrical concept. It is the starting of geometry. So we are learning about the basic geometrical concepts. So what do you know about a point? I think you all know about a point, but if I ask that what is the definition of a point, so I think you will be confused that what is a point. You just point, make a dot and say this is a point, but there is a definition of the point. So if we mark a dot in our notebook, so it is called a point. So these all are a points. But a point is a geometrical shape which has no dimension. So what is dimension now? Dimensions are called like length, breadth and height. But a point has no dimension, it has zero dimension. A point has zero dimension. Now what is the second concept? It is line. What do you know about a line? So we draw this point, so this is called a line. If we draw a line, so it is called a line. But what is the definition? Line is a geometrical figure. It is a geometrical figure with only one dimension, which is length. Okay, so what is a line? It is a geometrical figure with one dimension. What is a point? A geometrical figure with zero dimension. Line, a geometrical figure with only one dimension. And what is its dimension? It is length. Okay, I think now you got the definition. So this is the line. So this is called a line. It is also a line, and this is also a line. It has only length. Now what do you know about a plane? So what is a plane? Plane is just a surface. If you can touch the your table, so it is also a plane. If you can touch the your pages of the notebook, your book, so these are all called a plane. So what is a plane? So this is a plane. A boundless surface which is flat and smooth is called plane. So it is a boundless surface which is flat. It should be flat and smooth is called a plane. So these are some three basic concepts. First is point, another line, and third one is plane. It has dimension, line has one dimension, and plane has two dimension. What are these two? Length and breadth. And line has only length. So now we have three geometrical figures. By definition, we can't accept these terms. Hence, we consider these as representations of point, line, and plane. So these are the just representation of point, line, and plane. Three basic concepts are accepted without any question. So you can't question about what is a point, why this is a point, why point has no dimension. So without these questions, we have to accept these concepts because these are the basic or fundamental. These are called basic or fundamental. Point, line, planes are called undefined terms in geometry. So these are called undefined terms. Okay, now it's your question time. So the question is, a point has dash dimension, and your time starts now. Give the answer. A point has dash dimension. So how many dimensions a point has? 1, 2, 3 or 0? Okay, and your time is over. The correct answer is yes. I think you all guessed the correct answer. It is D. A point has no or 0 dimension. So correct answer is D. Okay, these are also some figures. We all know about these figures. First is ball, bat, and wicket. They are just like the instruments to play the games of geometry, without which the study of geometry can't be started. Okay, like these are the instrument to start a cricket. If you want to play a cricket, you all need these instruments. You need a ball, you need a bat, and you need a wicket. So like this, we also, if we want to study about the geometry, so we need some basic instruments to learn about the geometry. So we need players to play the game of geometry. So what are the players? Yes, these all are the players. They will play the game of geometry. Okay, so these are the players. So these are some basic shapes. All these are the shapes like the players to play the game of geometry. We have instruments, players to play the game of geometry. So we need instruments Like for cricket we need bat, ball, and we need some players. So same as this one, we have instruments and players to play the game of geometry. Without the rules no game can be played. So it's basic, because we should have some basic rules. So it is also applied on the study of geometry. Without the rules no game can be played. So we also need rules to play the game of geometry. So let's start the game of cricket. So in this game we have team India 21-0 in one first over, and Rohit Sharma is 12, Shikhar Dhawan is at 9, and the target is 321. So this is a game of cricket. So like this we will start to play the game of geometry. Yes, so game has been started. And this is 6. Isn't it very good? So we need rules to play the game of geometry. The rules are in the form of statements. Now what are the rules? So these rules are in the form of statements, because if we start to play the game of cricket, so we just need some rules. So like for example we have one rule that the number of wickets are 3. So we can't question that why it is only 3, why we can't play with only 1 wicket, 2 wicket, but this is just the basic starting rules. So number of wickets are 3. So this is just a basic rules. So like this we need some rules to start the game of geometry. So these rules are called statements. So these rules are called statements. These statements are accepted without questioning them. Same as we can't question that why there is only 6 balls in 1 over, why there are only 11 players in one team. Okay, so we can't question, because we have to start the game. So we accept these statements without questioning. So these are called assumptions. So these rules are called assumptions. So I think now you know about the assumptions, or it is known as common notion or universal truths. So these are called the statements which we have to accept without any question. So these are called assumptions, common notion, or universal truth. The rules used to play any games are called axioms. So axioms are the rules to play the game of geometry. So axioms are the rules to play the game of geometry. And the statements which are in general are called axioms. And rules used to play the game of geometry alone are called postulates. So what are axioms? The statements which are in general, which we generally used, so these are called axioms. And the rules which used to play the game of geometry alone, these are called postulates. The statements which are particularly related to geometry are called postulates. Axioms may be related to any branch of mathematics, for example algebra, geometry, arithmetic, but statements which are particularly related to geometry, these are called postulates. So the rules used to play the game of geometry are called axioms and postulates. So these are the rules. Now we will start the game of geometry. So to start, first we know about the axiom 1. So what is axiom 1? It's first rule, or it is called first rule. So let's see, we have three kind of angles: first angle, second angle, and third angle. So these are the three angles. And if you if you put one angle over the another angle, so they are equal. We can see that these angles are equal. So angle ABC is equals to angle XYZ. The first angle is equals to second angle. So these are called equals. And the second one is equals to third one. Okay. So first one is equals to second one, and second one is equals to third one. So obviously the first and third are equal. So the first and third are equal. So this is our first axiom. And what is this? Things which are equal to the same things are equal to one another. So I think you all know about this one. So it is very basic, but this is the first axiom. The things which are equal to the same things are equal to one another. Let's say the value of x is 1 and the value of y is also 1. So we can easily guess that the x and y are same. So this is the statement, things which are equal to the same. Here x and y are equal to the 1, same things, so both are equal. So things which are equal to the same things are equal to one another. Now what is the axiom 2? Look at this figure. So here we have a triangle ABC and AED. Here two sides are equal. AE, this side, AE and AD, both sides are equal. Again this side, EC and DB equals to, both are equal. Now these two lines are also equal. And if we add both of them, like AE and CE and AD and BD, so we again get the equals, AC equals to AB. So this whole line is equal to this line. So this is another axiom. If equals are added to equals, then the whole are equals, and it can be applied on another branches of mathematics, not only on the geometry. If equals are added to the equals, then the wholes are equal. So I think you know about this axiom when you solve the equations, linear equations. So to solve the equations we use this axiom, axiom 2. Now there is another axiom 3. So there is an angle B and angle C. Look at these angles, angle ABC and angle ACB. So both angles are equal. So both angles are equal. And there is another angle ABD equals to angle ACE. This angle ABD, the upper one, and the angle ACE, both are equals. And if we subtract both of them, So we again get the equals. Then angle DBC is equals to angle ECB. Angle this DBC is equals to angle ECB. So this is another axiom or statement. If equals are subtracted from equals, then the remainders are equal. Okay, and it can be applied on geometry also. So these are three axioms. We have three axioms. Things which are equal to the same things are equal to one another. If equals are added to equals, then the wholes are equal. And if equals are subtracted from the equal, then the remainder are equal. So these three axioms concern equals or equal things. So these three axioms are related to the equal or equal things. Now another axiom 4. Now we have two circles. First is shorter and another is bigger one. So if we check, so these are called the concentric circles. There is another circle 4 centimeter and 4 centimeter, and these are equal circles. These circles have the same radii because they both have same radii, which is 4 centimeter. So things which coincide with one another must be equal to one another. So this is another axiom. We have axiom 5. So this is another angle 70 degree, and this angle is less than, or angle DBC is 38 degree. So obviously this is lesser angle and this is greater angle. The whole is greater than its part. So this is again a very important axiom. The whole is greater than its part. What it means? If you have a whole roti, and if you make a part of this one, so this whole is always greater than this part. Now axiom 6. Things which are double of the same things are equal to one another. So if you double, if we have x equals to y, and if you make double, so the things are also again equal. The area of the bigger circle is equal to twice of the area of smaller circle. And it is applied on all the things. The area of this bigger square is equal to the twice of the area of this smaller square. Now will the areas of these bigger circles and square be same? If both has the same area, for example, let it is 10 meter square, it is also 10 meter square, and if you double this area, so it will be 20 meter square, and this also 20 meter square. Okay, so will the areas of these bigger circle and square be same? So answer is yes, because of this sixth axiom. Now another axiom 7. Things which are half of the same things are equal to one another. So it is again same as the axiom 6, which makes double, but it makes half. So if the x and y are equal, then their halves are also equal. Clearly by axiom 7, the areas of these smaller circle and squares are the same. Okay, now again question time for you. Which of these statements do not satisfy Euclid's axiom? And your time starts now. Things which are equal to the same things are equal to one another. If equals are added to equals, the whole are equal. If equals are subtracted from the equals, the remainders are equal. The whole is lesser than its part. Okay, so which of these statements is wrong, or which of these statements do not satisfy Euclid's axioms? Okay, give the answer quickly. Okay, class. So the D statement is wrong because we know the whole is always greater than its part. So what is the answer? It is D. D is the correct answer. The statements which are particularly related to geometry are called postulates. So first we learn about the axioms, and these are related to any branch of the mathematics. Okay, I think you understood. Any branch means, for example, postulate, for example, algebra, for example, arithmetic. But the statements which are particularly related to geometry, so these are called postulates. So first postulate is, we have some points, this is line. How many straight lines can be drawn from any one point to any other point? If you are given one point and other point, so how many lines can you draw? Only one. A straight line may be drawn from any one point to any other point. If we have to connect 2 points, so we will make a straight line which connect all the points. A straight line may be drawn from any one point to any other points, so we can draw any straight line. So this is our postulate 1. Given two distinct points, there is a unique line that passes through them. Okay, if you are given only 2 points, then only one line we can draw. What do you call the part of the line which has got definite length? So it is called line segment. So there is a difference between line and line segment. So this is a line. A line can be it can be go from one point. Okay, so it can be draw far. It has not a definite length, but if we have a part of the line which has definite length, so it is called line segment or terminated line. This terminated line can be extended on either side indefinitely. So then it is called line. So what are the geometrical postulates? So another postulate is circle. So you can see that there is a circle and this is called center, and this is a radius. So we can draw a circle with one center and one radius. So if you are given any straight line segment, a circle can be drawn having the segment as radius and one endpoint as center. So I think you all know about how to draw a circle. You are given a given point, you place your compass at this point and make a definite length and then draw the circle. So this is postulate 3. We can draw a circle using a point and definite length. Now postulate 4, which angle is this? Do you know which angle is this? Yes, it is 90 degree. 90 degree is always shown like this. So this all angles are 90 degree. All right angles are equal to one another. This postulate is concerned about the right angles. So the postulate 4, look here, the postulate 4, it is related to right angles or 90 degree. So all right angles are equal to one another. So they all are equal. Okay, now your last question. Which of the following statement is true? And your time starts now. Only one line can pass through a single point. Infinite number of lines pass it through two distinct points. A terminated line can be produced indefinitely on both sides. If two circles are equal, then their radii are unequal. So which of the following statement is true? Okay class, your time is over. So the answer is C. A terminated line can be produced indefinitely on both sides. Okay students, so what did we learn today? Today we learned about the geometry and we learned about the axioms and postulates. So what are the axioms? These are related to any branch of mathematics. These are related to mathematics. And then we have postulates. These are specially related to geometry. And all these instruments, all these statements are true. We have to accept them without any question as true. So we learned about some axioms of Euclid and also some postulates of Euclid. So now what you have to do, you have to learn about and study about these axioms and postulates. So which axiom is related to which part of the statements. Okay, so now it's time to end the class and we will meet in next class. Okay, till then, goodbye.